Welcome to this month's In the Labs with Tim Sway. I am Tim Sway, and right now we are not in my lab, we're in my guitar truck, and I'm here to demo this month's project, which is this electric guitar that is actually ambidextrous and will look right and be able to be played by left-handed and right-handed guitar players, which is a simple flip of the strings. We'll talk more about that later, but first, what's super cool and exciting about this project is a couple things. I've been asked several times to make just straight-up guitar projects for users of Vectric software, and the other thing I've been asked is that I can do them without using Aspire by using all 2D cutting paths. So that's exactly what this guitar is. I used only VCarve Desktop to design and cut this, and it is all done using 2D guitar toolpaths. And if you don't like this shape, because of the file and the way it's designed, you'll be able to extrapolate your own guitar shape onto it and make your own design using the basic foundation that I laid in this free download. So go ahead, log into your V&Co account, download these files right now, and then watch along and I'll show you how it's done. I want this project to be accessible to as many Vectric users as possible, which is why I did it in VCarve Desktop. You'll see I have other guitar files that I've got many of them, and I just went and copied and pasted one of those into a new document to create this guitar. I have all the geometry in the holes and the alignment already set up from these other guitars, so I often will copy and paste them into new files. And here I am just sort of putting stuff onto different layers so I can start to create my body shape. The plan is to have this guitar be completely symmetrical, so the top and the bottom are exactly the same. And so I just created a box on the top half of the file and started messing around, moving nodes around to start creating my shape. The goal here is to have as few nodes as possible, so all my curves and shapes are nice and smooth. But I had to experiment a little bit with how I wanted to set them up, whether I wanted to be smooth points or not. And just right now I'm clicking around and seeing what looks good to me. Then there's also some physical things I need to do, like I need to make sure it's about guitar size so it doesn't look weird. And I need to make sure that that neck block is properly supported where I'm going to bolt the neck to the body. And you know, it's really amazing how much you can do by just moving one of those little nodes around. And now you can see I've got a shape that I'm starting to like, so I just started copying it and mirroring it to the bottom of the file to get an idea what the whole thing looks like. Now, to be honest, I have already made a file which I'm going to jump to in a minute. Right now I just went and recreated what I did to show you the basic idea, and then I'm going to jump over to the one that I already created that I like a little bit better. Now, we're going to do this sort of a fluting toolpath idea that I came up with a little bit later, and what I needed to do was create a section in the center of the guitar that is going to be flat so all my hardware and everything mounts properly, and that's my final finished thickness, and then have the shape come off of that. And I went with an oval to kind of counteract all these sort of jagged shapes that I'm creating. And here you can see there's the body that I had already finished, and we're going to jump into that now to start creating toolpaths. The tricky thing about an ambidextrous guitar is where you put the controls, like the volume and whatnot, because if you put it onto the top, it becomes the bottom when you flip it upside down. So they have to be somewhere near the center, in that center core of the instrument. But they don't have to be perfectly parallel. I see a lot of times when these guitars are made this way that the maker will create a straight line, and I just don't think that looks good. So I'm not worrying about that right now. I'm just putting them in that general area so that it won't look exactly the same upside down, but it'll look fine either way is kind of the end result. So now that I have all my geometry figured out, I have my cavity cut, I wanted to do this fluting toolpath, and that requires me to have a whole bunch of lines to follow with my end mill. Using the copy along vectors tool, I just created one line, and I figured I'd copy it right around the body of the guitar, but of course I did it backwards the first time. So I did this once to get a look at it, and I realized that I need to make a longer line to make sure it goes all the way to that center oval shape that I created. So I move it over, kind of figure out what I need to do, and then I try again. Whoops. I set the tool to make these lines spaced about 2/10 of an inch apart, so my 1/4 inch end mill would overlap a little bit. And now you can see it made hundreds of these lines, and I have a real mess on my hands, right? But thanks to this new trimming function on the scissor tool, you can see I can just click and hold the left mouse button and drag around and get rid of all those excess lines real easy until you mess up like I did a second ago and cut into the wrong line. But you always just do the Command Z to undo your mistakes, of course. So I went around and cleaned these all up, and I knew that there'd be a few spots that I would need to edit, which I will do here. See where the lines cross each other? I could just leave them like that. Well, first I had a couple that were too short, so we fixed those. But you can see over on the left there at the top, a whole bunch of my vector lines crossed each other, and I could probably just leave them like that, but I thought instead that I would see if I could actually create a little bit of additional shape by removing the crossing sections and extending these lines out to make it so it would sort of almost form like a ridge or a peak along these junctures. So, quick tip with the scissor tool, if you just cut the line where you want it to disappear first, and then, you know, by just snipping down with the scissors, then you could go back and just delete the remainder of the lines by getting out of your scissor tool and just going to your regular pointer tool and just clicking and deleting them a little bit faster. So now I created a second line around the guitar, just a little bit past the body, and just to make sure that my fluting toolpath would go past the body, and use that scissor tool again to trim all the excess lines. But I also had to copy and paste all these lines I created to the backside of the guitar because I want to do this on both sides. So now I'm ready to start creating toolpaths. The neck pocket and the pickup pocket are pretty straightforward. You just cut pockets at about 0.65 inches deep is usually plenty. And then that other rectangle that's on the face of the instrument is just there for placement of your guitar bridge. But now here, as I'm getting ready to create my fluting toolpaths, I realize that I have to have all of these toolpaths start on the inside and end on the outside. And my lines are a mess, so I had to go through and manually flip those around. So you see those green points are where the toolpath will begin, and it ends at the black. So when you're setting your fluting toolpath, which we'll do in a minute, you want to set your first depth at the green dot and then the lower depth at the black dot. So I want my guitar to go down and get thinner as it gets to the edge, and I need to make sure all of my vectors start on the inside and then go to the outside. So let's talk about this fluting toolpath. What I did is I started it at the very top, the green dots on the inside of the guitar, at 0.1 inches, and I went down to the end of the file to 0.25 inches. So it's going to make a 0.15 inch slope as it goes down. And you can see that there's all sorts of different options of the way you can shape these toolpaths. And I experimented a little bit and ended up with just a linear shape that went down. And here you can see I got a couple spots I got to fix, but you can see what's happening is that what it does now is the end mill will start its cut at one height and finish it at the other. Now I know where it's starting because I'm just plunging end mills into the wood that it's not going to be a perfectly even line, and so that's why I started it at 1/10 of an inch deep, because I then created a toolpath around the oval shape right on the line of the oval shape, so it would be a half overlap and it would clean up that whole edge when I was done. And then as you can see, I made sure to have my fluting toolpath go past the edge a little bit, so when I cut that profile out, it'll be nice and clean too. On the back of the instrument, I had to do the same thing with the fluting toolpaths, and then there's also a cavity that I had to hollow out to put my electronics in. It's all pretty basic 2D cutting, and the entire file is cut with just 1/4 inch end mill. You'll notice those 3 circles that I have around the exterior of the guitar. Those are my indexing holes, and I have them mirrored on the other side of the instrument, and you'll see how I do that to make sure that I have my piece properly aligned when I flip it. And now we can start kind of looking at some of our toolpaths and making sure they all look good. There's that oval circle around the oval. There's my fluting toolpaths. And of course I put some tabs around the edge too. Now I created this guitar out of a block of wood that I had on hand. It was a bunch of glue ups of some cut-offs of other projects that ended up being about 12 3/4 inches by 18.5 inches by 1.35 inches thick. That's a little bit tight to fit most guitar shapes into, and it's also a little thin for most guitars. They tend to be over 1.5 inches, more like 1 5/8 inches, 3/4 thick, but I like guitars a little thinner, and that's about as thin as you can get away with. When you make your guitar, if you want to make it thicker, you can, and you can leave all these toolpaths exactly the same. Just change the thickness of the wood, and then your overall thickness on the exterior of the guitar will just be a little bit thicker as well. Right now, the way I did it, it's about 0.65 inches thick there. So if your guitar was 1.5 inches thick, you'd be like more like 0.8 inches thick. It'd be nice. Here's my blank that's a glue up of all other guitars that I've made. It's the edge pieces that I cut off and glued together. And then I thought it'd be fun to paint the entire thing with Stuart Semple's Black 3.0. It's the blackest paint on the market. And now that way I can cut away the paint and reveal the guitar underneath. And this is the end mill I use. It's just a 1/4" end mill. That's a little bit longer than most. Sometimes you need that to cut through thicker guitars. I merged all my toolpaths and started on the top. That first box you can see that I cleared away on the right was just to reduce the neck a little bit so it would line up with the body that I carve away here in my fluting toolpaths, not the black part of the wood. I wanted to just lower that a tiny bit. And there's my pickup hole, and you can see the fluting toolpaths starting to happen now, which is really exciting and fun to watch. I'm not quite sure why it started on the deep end and went up to the shallow end, but it worked exactly the way I wanted it to, so I'm not complaining and I'm not worried about it. I also drilled my indexing holes and cut a little bit away from the profile on this side, so when I flip it over and cut the profile out, I don't have to cut as deep. Now here you can see I zero out to the wasteboard of my board, and I cut my reversed mirrored indexing holes right into my wasteboard, and they're exactly the thickness of a pencil. I always save my little scrap pieces too, so some of those pencil pieces have been used in 20 or 30 projects. And now I can flip my board over and line up those holes with the pencil marks, and now I know that as long as I don't screw up and re-zero my machine, it's going to be perfectly centered out. And now I can cut the back out, starting with the cavities, of course, and then going into my fluting tool paths, and then the final profile. And that's really it. There is a vector included in the file that is 1/100th of an inch smaller than that back cavity hole that you could use to cut out a cavity cover.
I painted this guitar first because, for one, I thought it would be fun to watch the machine cut the wood away and reveal through the paint, and the other was to keep these lines nice and tight, whereas it would be a little bit more difficult to maybe paint this after it was cut. So the goal will be to try to protect this paint as much as possible while cleaning this up, and I'm sure I'll end up having to touch it up here and there, but we'll see. I think it was kind of fun to do, and you can see here that since this isn't a 3D carve, it's a fluting toolpath, it's not super clean, and it wasn't done with a ball nose, which would, with a heavy overlap. So I need to go in and sand this, which is what I expected to do, and it won't take long at all to sand this out. But this is just a nice little sort of cheat way you can start doing sort of 3D sculptured things with 2D software and 2D toolpaths. It works.
I think I mentioned earlier I could have created more lines to do fluting toolpaths on and overlapped them more, which would have meant maybe a little bit less sanding, but it would have meant a lot more machine time, and it only took me 3 minutes to get it smooth with my palm sander.
I mentioned before that I wasn't too concerned about making these holes parallel, and then I went and I forgot to put a hole in for my 1/4 inch jack, so I just drilled that. Nothing's parallel, so it'll look like this one played right-handed and this one played left-handed, and I was fine with it not being exactly the same as long as it didn't look weird. But in your file I've added that hole and I've changed this configuration a little so it'll be a little bit better looking for you.
This is always one of the most nerve-wracking parts of making guitars, but you have to drill these holes sometimes to get wires to run through. And so I had this 1/4 inch drill bit that I figured the easiest way to get a straight shot into that cavity in the back was to just go straight through the neck hole, through the pickup, and right into it. And then you also need to create a little hole underneath where the bridge will go for a ground wire to go, and that requires drilling at an angle, which you'll see in just a minute, where the wire goes right there at the bottom of your screen. So it's nice to use an 1/8 inch long drill bit to drill that hole and really plan your angle properly, because if you're off a little bit, you'll end up drilling to the back of the guitar instead of drilling into the electronics cavity. And I'm including a wiring diagram for how to solder this all together, but we're going to talk about some parts that you will need, so let's do that now.
Of course, there's going to be some hardware and a neck and whatnot that you're going to need to purchase to finish this guitar. If you're new to guitar making, you might not know exactly what you need and all the names of the things. So I'm going to include a list of what you'll need to purchase to finish this guitar as I'm designing it and building it here in this video. I'm not going to put direct links to anything because I don't have any sort of affiliate programs. I don't really like to do that. But all the names and stuff will be there, and they are pretty easy to find if you search the terms that I wrote down. First and most importantly, you're going to need a guitar neck. making guitar necks is pretty complicated, and you probably don't want to do that for your first build. Now you can go to eBay and you can find necks like this relatively easily and inexpensively, but the problem with most of them is they're like this. They're already sort of partially shaped and they're pre-drilled, so now it is no longer ambidextrous. If you flip it upside down, it looks different. You look like Jimi Hendrix. If you want to look like Jimi Hendrix, great. But what I'm trying to do is make this guitar that totally looks the same both directions. So what you need for that is what's called a paddle head guitar neck. And you can see why they call it that. This is a very nice one. I can find these on eBay for $40 to $50 usually. It's just made of maple. And the other thing for the plans I have is that there are a couple different scale lengths, which is the length of strings for guitars. This is a 25.5-inch scale length guitar neck, which is pretty common. So again, all of this stuff will be written down and accompanying the video. Next, you will need to attach that neck to your body, and this is one way you can do it. You can buy one of these neck plates that comes with the screws. Then you will need tuners to put up at the top of the headstock. The tuners are just these little things that we use to, you know, tune the strings. And the important thing when ordering these is you want to get a set of 3x3 tuners, because we're doing this parallel headstock with 3 tuner knobs on each side. They also sell them with all 6 of them in a line, and they actually are a little bit different if they're on the other side. Strap pegs, you can also be creative with these and just make them out of nuts and bolts and stuff like that. You'll need a guitar bridge, and the important thing with this is that you want to have a top-loading bridge. And that way you can just bolt it on and the strings go right through. And if you don't get a top loading bridge, you can see this one is actually both. The other thing you can do is you can actually drill holes through the body of your guitar and run the strings to the back of the guitar. Tone snobs think this helps with sustain and whatnot. I personally like top loading ones because I was a performing musician for a long time, and these were the fastest and easiest way to change strings when you broke them on stage, so I always prefer that. For your electronics, you will need 2 500K potentiometers, and you'll also need a capacitor, which is just these little things. They're usually a nickel or dime a piece, and that will act as your tone capacitor, which bleeds some of the high end off of the signal to make it sound bassier. You'll also need a 1/4-inch jack to plug into the guitar, some wire. This is a string retainer that goes up here to put pressure on the strings after they cross the nut. There's a couple different ways of doing this. Most guitars tend to have, they don't worry about these strings. It's the longer strings out that have a slighter angle that you need to put pressure on. But I always just like to put a lot of pressure right here behind the nut at all 6 strings. I just find it simple, easy, and clean looking. And of course you'll need a pickup. The hole I designed in this body is for what's called a humbucker pickup. It's a standard size, and I am using this one here that I already mounted, and I mounted it directly into the body. The way these are typically mounted is they are hung from sort of a plastic trim ring, so you would run a screw into the pickup like this, and then you can adjust the height of it by going up and down, and then this trim ring sits on the instrument flush like that. This one's too thick for this particular instrument. You need a flatter one for this design. That's the way you can do it. If you like that look, I personally would rather see the man behind the curtain. Obviously, there are a gazillion ways you can put together electric guitars, and I'm doing this one specific, kind of weird ambidextrous thing. And I'm also doing a stripped down version of it. It's only got 1 guitar pickup, it's only got 1 volume knob, 1 tone knob. When you go to your V&Co account and download these files, you can do whatever you want with them. You could copy and paste the pickup cavity and put a second one down, or change it to hold different style pickups. You could change the body shape. The great thing about this file is that it's all set up for you with the neck position, the neck pocket, and the bridge positioning, so you can just kind of work from there and design your own stuff. I would recommend cutting out test cuts of all of these holes in other product, like just some scrap wood or whatever, to make sure they're all going to fit, because I'm not providing the neck and the pickups for you, so the ones you buy might just be a little bit different, but it should all pretty much work. Now for the shameless self-promotion part of this video. Over at my website, newperspectivesmusic.com, I sell DIY guitar and bass guitar kits. They use a slightly different pickup, and they're a little bit different than this, but they are designed for people that don't have CNC. So when you buy it, you get like literally every part you need it: the neck, the nuts, the screws, the strings, everything except the block of wood to cut the body. And then I provide physical templates and instruction for people to then go make their own guitar bodies in whatever shape and style they want. But I also include some downloadable PDFs and some SVGs that CNC users might find useful as well. So if that's something that interests you, if you want to get into guitar making and you don't even like this body style, there's a couple other body styles there that are all ready to go. You could download those and extrapolate them with the information you're getting from this video and make CNC files very easily.
Next we need to make that headstock, and I started by very carefully finding the center of my paddle, and you'll notice that I found where the square shape began and measured from there, and sort of planned out how I want my headstock to look before going over into my VCarve desktop. And again, I copied and pasted an old headstock file that I had on hand, and then used that to sort of start planning my shapes and whatnot. And I messed around with it a little bit till I found something just very simple. Now notice this line I just put around the exterior of the headstock. This is important. So first I'm going to drill out these tuner holes, but then when I go to cut the profile shape out, I have to cut on the line because the vector is not closed. You can't cut inside or outside of a vector that is not a closed line. So that's why I went out half the width of my 1/4 inch end mill, 1/8 of an inch, created that line around there, and then followed on the line with my 1/4 inch end mill so it would cut right up to the shape that I want to keep without cutting into it. I probably should have cut a test piece, but I was feeling pretty good about this, and so I just very, very, very carefully centered my neck under my end mill.
I can securely screw this to the waste board here, but then when the neck comes undone, it will fly free. I could put tabs, but then I'd have to clean them up. And then the other thing I can do is I can drill my tuner holes, and then I could run through those holes some kind of screw supports to hold it down in place there. But I'd have to use a washer or something big, and it'd be getting close to where my profile cut is going to be. So instead what I'm going to do is the trick that I did in my last video for Vectric, where I created a mounting system for my little toy trucks that we made by screwing down this caul clamp. So I'm gonna set that up. I think these are going to become a very important part of my workflow on my CNC machine. These caul clamps work great to quickly hold stuff down safely, and for the most part, if I did make a mistake in my calculations and my bit were to hit this, the odds of them hitting metal are pretty slim because it's mostly wood, so I probably won't break too much stuff. Now I'm going to cut that profile, and everything should be fine, but when it's doing its last pass, I'm just going to hang out and put my hand here just in case. It's totally fine. I didn't have to, but, you know, better be safe than sorry. Well, that worked really well. I could have used a V-bit to carve a logo in here or something while I was doing this, maybe infill it with some epoxy, but I have a laser, so I'm going to laser engrave my logo on this instead.
That guy bot was pre-finished, so I only had to finish the areas that I just worked on.
I obviously can't cover everything there is to know about guitar building in this one video. Fortunately, we have the internet, and there are thousands and thousands of videos about guitar making there, including probably a couple hundred of them on my channel alone, which is youtube.com/TimSway. Feel free to go there where you can find some, I actually have a few sort of tutorial type videos about fretting and you know, wiring and stuff like that. Go ahead and check those out, or just ask me a question and I'll do my best to answer you. It is one of those skills that it starts, you know, where you can make something and every day you learn how much there is to learn. But that's what keeps me coming back for more. Just like CNC. I am left-handed in everything I do in life except play guitar, and that's just because my guitar teacher when I was young didn't know that I was left-handed. So that actually worked out really well for me because left-handed instruments are not as readily available. So being left-handed sensitive, I love making left-handed guitars for clients. And then it made me think about this whole idea of doing this ambidextrous guitar. Now obviously, most people making a guitar are not going to be wanting to flip it upside down and play it. So if you're designing this and making this, you can, you know, have a little liberty with that. Maybe move the controls to another location or whatever. But for me, I wanted to make this truly ambidextrous, and I did. So now I have it strung to be played by a person who plays right-handed like myself. In order to string this to be left-handed, you would do everything exactly the same, except you would just have to remove this plastic nut from the top of the neck and flip it around because these slots are like the widths of the strings. So just take that out, flip it around, put it back in, and then you would string it
this way with the low string on the bottom and the high string on the top going this direction. And of course you would need to intonate the bridge accordingly if you were swapping it or whatever. But it's all done exactly the same with this, and that's what's kind of fun about it. Thank you all very much for watching. I hope this is what you were hoping for, because I know I've been asked many times to do this and I want to make you all happy now. But I do want you to keep in mind that if this is your first time making a guitar, there's a lot of things that can go wrong. There's a lot of steps and there's a lot of stuff to do. But I have the utmost faith in you as a CNC operator to be able to figure it out and solve all the problems that may arise. Just be patient with yourself and don't get frustrated if your first guitar ever isn't a Stradivarius. I know they don't make guitars, but you get the point. So just go out and have fun, make your first guitar, and then here's the really bad news though, is that making guitars is very addictive, and I can almost guarantee you it will not be your last. So again, thank you very much for watching. Have a great day and be good.